Hi maths students, I'm Mr. Hajgassam and today we're going to be learning about algebraic fractions. Now let's start with this problem, x squared divided by x squared. How would we simplify this? Well, if we think about this problem, any number or any term divided by itself is equal to 1. So if I had, for instance, 6 divided by 6, this would be equal to 1. If I had 100 and 6 divided by 106, that would still be 1. So likewise, x squared divided by x squared will be 1, x divided by x is still 1, or if I had ab divided by ab, that's still equal to 1. Now, another way of looking at this, which will be helpful when we're simplifying algebraic fractions, is that x squared over x squared can be written as x times x divided by x times x. Now, over here, the x's will cancel out. So this x divided by this x will give us 1 over 1. It's not going to be 0, just because they cancel out, it doesn't mean we'll have 0 over 0. It's going to be 1 over 1, and then times x times x. Well, this x and this x will cancel out. So what we'll have is 1 times 1 and 1 on the bottom. So every time we cancel out two terms, they simply become 1. And 1 times 1 is 1, 1 times 1 is 1, and 1 divided by 1 is simply 1. So we need to be very good at cancelling out terms that are alike. So if I just clear all of this, and we can do another example. So here we have x over 4 divided by x over 2. So we can write this as a fraction. So this is going to be x over 4 divided by x over 2, which can be rewritten as, if I just draw this line again, a bit nicer, there we go, which can be rewritten as x times x times x times x. So we have 4 lots of x's over x times x. Now, how would we tackle this problem? Again, we can cancel out one set of x's, so that will give us 1 times another set of x's, so that's going to be 1 times 1, and then what we're left with is times x times x. So 1 times 1 times x is simply going to be x squared. 1 times 1 is 1, and this is simply x squared. Now, if you've done laws of indices, you may approach this problem using laws of indices, but I just want us to have a good understanding of how we cancel out terms when we're dealing with algebraic fractions. Likewise, in the second example, we have a squared divided by a cubed. So I'm just going to rub out what I've done. We have a squared divided by a cubed, and that will give us, or if we were to expand this problem, we will have a times a divided by a times a times a. Once again, we need to cancel out the terms that are alike. So a and a will cancel out, which will give us 1 and 1 times a and a will cancel out again, 1, and then we have 1 left on the denominator. So 1 times 1 is 1, 1 times 1 times a is simply a. So the answer to a squared over a cubed is going to be 1 over a. The answer to x to the power of 4 divided by x squared is going to be x to the power of 2. All right, now what if we were to think about the highest common factor? So another way of approaching this problem is to think about the highest common factor of each term. So in this example, we have x squared as our highest common factor because both terms, oops, sorry, if I just undo that. Both terms have a common factor of x squared. X squared goes into x squared, and x squared also goes into x to the power of 4. Similar to if we had normal numbers like 6 over 3, for instance, where we could simplify this by dividing both terms by 3, as 3 goes into both of them. 3 is the highest common factor of 6 and 3. So what we'll end up with is 2 over 1, which is simply 2. Likewise over here, if I just rub all of this out, what we will have is x squared going into x to the power of 4 and x squared going into x squared. So x squared divided by x squared is simply 1, and x to the power of 4 divided by x squared will be simply x squared. So what we'll end up with is x squared. Likewise over here, a squared over a cubed, but the highest common factor is going to be a squared, because a squared will go into both terms. So I can divide both by a squared. A squared divided by a squared is simply 1. A cubed divided by a squared is simply a, which will give us an answer of 1 over a. So this is another way of thinking about this problem, but I think the cancelling method is pretty nice and easy to deal with. So let's move on and do some more examples. So we have x to the power of 5 divided by x squared. We can think about this as the highest common factor of x to the power of 5 and x squared. So the HCF is going to be x squared, because x squared goes into both of them. So we would have to divide the denominator by x squared, divide the numerator by x squared. We will have 1. X to the power of 5 divided by x squared is going to be x cubed. So we will be left with x cubed. Alternatively, we could have rewritten this as x times x times x times x times another x, 1, 2, 3, 4, 5, divided by x times x, and then cancelled down. So x and x will cancel out, leaving us with a 1 on the numerator and the denominator. X and x cancel out again. And then we're left with 1, 2, 3 x's. So x times x times x. So what we'll have is 1 times 1 times x times x times x. That's going to be x cubed over 1 times 1, which is 1, which will give us any number divided by 1 is simply itself. So x cubed over 1 is simply x cubed. All right, have a go at the next one, please. So b to the power of 3 divided by b to the power of 7. You can pause the video and try this. All right, so this one, again, the highest common factor is going to be divide by b cubed, divide by b cubed. What we'll have is 1 over b to the power of 4. Let's do another example. Again, as I'm doing these examples, you can pause your videos and have a go at them and then check your answers. So we have ab cubed divided by ab. Slightly trickier problem. And we do both methods with this one. So the highest common factor, they both have an a, and they both have 1 lots of b. So the highest common factor is simply going to be ab. So ab divided by ab is 1. ab cubed divided by ab is going to be b squared. So the answer is going to be b squared. Now I could have rewritten this as a times b times b times b over a times b. Now the a's cancel out. I have 1 and 1 on the top and the bottom. The b's cancel out. I have 1 on the top, 1 on the bottom, and then I will have a b and another b, and that's all the terms dealt with. 1 times b gives us b squared over 1, which is simply b squared. Okay, and if I clear all the drawings, we can do another example. So now we're dealing with numbers as well. You can pause the video and have a go at this. But the highest common factor is going to be 16 goes into the numerator and the denominator. So 16 is a common factor. They both have 1x as a common factor, and they both have y squared as a common factor. So this is going to be 1, 16xy squared divided by 16xy squared is 1. And over here, 16 divided by 4 by 16 is 4. X squared divided by x is simply x. And y squared divided by y squared is simply 1. So our answer will be 4x. Now again, I can rewrite this as 64 times x times x times y over 16 times x times y. Now 64 over 16 is going to be 4 over 1. As we said, 64 divided by 16 is simply 4. And then we need to cancel down. So x and x cancel out. So that's going to be times 1. We have times x. No more x's to cancel out with. The y's will cancel out. So we'll have times 1, and these two y's cancel out. And then we can write times 1 times 1. So what we'll have is 4x over 1, which is simply 4x. Now again, you don't need to do this method for every problem that you have. However, if you get stuck, this is a really effective method to follow. Okay, and moving on to harder examples. Now here's a statement. It says, is this statement true? So 2 plus 6 over 4 plus 2 is the same as 2 times 6 over 4 times 2. And the reason why this statement can be true is because both fractions, the 2's on both fractions will cancel out. So what we're essentially saying is that these two will cancel out and these two will cancel out. So up here we're left with 6 over 4, and up here we are left with 6 over 4. Now, you may be tempted to think this is true. However, it's not. This statement is false. 2 plus 6 over 4 plus 2 is not equal to 2 times 6 over 4 times 2, because in this scenario, whilst the 2 cancel out because the 2's are factors, in this case, these 2 are not factors. We're simply adding 2 to 6, and we're simply adding 2 to 4. So we're adding to the numerator and we're adding to the denominator. And what our problem will look like, if I just get rid of this, what our problem will look like is going to be, we have 2 plus 6 is 8, 4 plus 2 is 6. That is not equal to 6 over 2. Over here, the 2's will cancel out. Over here, we just have to add on the 2's. 8 over 6 will simplify to 4 thirds. And 6 over 2 is simply 3. Sorry, 6 over 4 I should have written. If I just rub that out, it's going to be 3 halves. 4 thirds is not equal to 3 halves. Therefore, these two are not equal. And just be aware the 2's in this scenario don't cancel out. So when we're dealing with addition or subtraction, don't automatically assume, oh, I have a 2 on the top and I have a 2 on the bottom, so I can cancel them out. That would be completely wrong. And we've used the numbers to show why that is wrong. All right, so if I just clear the drawings and we can do some examples. So over here, what we have is 4k plus 8 over 2. How we can do this is 2 methods, but I prefer the factorising method first. Well, I prefer the factorising method, but I will show you the other method first. So we can rewrite this as 4k over 2 plus 8 over 2. And what that will give us is 4k over 2, well, 4 divided by 2 is 2, so we'll have 2k plus 4. So this will be our answer, 2k plus 4. If we were to factorize, what I would need to do is take out a highest common factor of 8 and 4, which is simply 4. And then in the brackets, I will have k plus 2. And if I expand this, 4 times k is 4k, 4 times 2 is 8 over 2. Now I need to see what cancels out with what. 4 divided by 2 is simply 2. So what I'll have is these two cancelling out, leaving me with 2, and then k plus 2 on the inside. And if I was to expand this, what I'll get is 2k plus 4, as I got over here. Now you might think this step was a lot longer. However, for more complicated problems, this step is a lot more effective. So whilst right now this was quite quick, with more difficult problems, this is a better method to utilize. All right, let's do one more example then. So I'm just going to do the factorizing method here. So I can factorize or factor out. If you just bear with me 1 second so I can move this. There we go. I can factor out 5, as 5 is the highest common factor, and then I'll have 7m minus 3n on the inside. 5 times 7m is 35m. 5 times minus 3n is minus 15n over 5. Now, these 5s cancel out. So what I'm left with is 7m minus 3n. All right. And moving on. So slightly trickier example. Now you might be tempted, as we discussed earlier, to say, well, there's a 3x here and there's a 3x here, so they will cancel out. I'm going to have x over 2 over 9. But remember, we're adding on 3x to both the numerator and the denominator and the numerator. So this would be wrong. This is why factorizing is required. So if I factorize the numerator, I will have x on the outside. X is the highest common factor of the two terms. X on the inside plus 3. And then over here, 3 is the highest common factor. X on the inside plus 3. Now I have a multiplication problem. Now what I'm saying is x times, in brackets, x plus 3, and 3 times, in brackets, x plus 3. So x plus 3 and x plus 3, they're essentially factors of x and 3. So what I need to do is cancel these factors out. So what I'll be left with is x over 3. So this and this cancel out, leaving us with x over 3. Let's do one more example. Now again, I need to factorize, so I will have to factor out 3, and then I'll be left with x minus 2 on the inside. Over here, I will factor out 2 and x minus 2 on the inside. Just double check to see you factorize properly. So we have 3 times x is 3x, 3 times minus 2 is 6, and then we have 2 times x is 2x, 2 times minus 2 is minus 4. Now we need to see what cancels out with what. So x minus 2 and x minus 2 cancel out. So we're left with 3 over 2, which is 1.5. So don't be tempted to simply cancel out the like terms in your, or the identical terms, I should say, in your fraction problems when you're adding or subtracting terms onto each expression. All right, now let's have a go at some more. So we have x minus 3 over x squared minus 3x. Now, if you want to pause the video and have a go, by all means do so. What I'm going to do, well, I can't factorize x minus 3 because they don't have a common factor apart from 1, but we don't factor out 1. And then over here we have x squared minus 3x. X is my highest common factor. X minus 3 will be on the inside. So now I can cancel out x minus 3 and x minus 3. So that's going to be 1 over x. Remember, when we cancel out terms, they don't just disappear, they become a 1. So as this gets cancelled out, it becomes a 1. As this gets cancelled out, it also becomes a 1, but we're not going to write 1 over x times 1. We're simply going to write 1 over x because x times 1 is just x. All right, let's have a go at another one. So x plus 2 squared over x plus 2. Now, this x plus 2 squared means we have x plus 2 multiplied by itself over x plus 2. Now we have one set of x plus 2's that cancel out. So we're left with x plus 2 over 1, which is simply x plus 2. And let's do one more. So here we have 5x over 35 plus x over x plus 4. Now let's start by factorising. So we'll have 5x plus 7 over x plus 4. Now in this case, we can't simplify this anymore. Nothing will cancel out. So what we'll be left with is we can either leave it in this form, or we can say cannot be simplified. And really, you wouldn't get a question like this in an exam. However, or they wouldn't ask you to simplify this. However, this was a good test for you to realize whether you can actually simplify it or not. All right, and one last example. So we have 3x plus 12 over x plus 4. Again, pause the video to have a go at this. What we'll have is 3 on the outside, x plus 4 on the inside as we factorize this. And then we have x plus 4 on the bottom. So x plus 4 and x plus 4 cancel out. We'll be left with 3 over 1, which is simply 3. Now I'm just going to raise the difficulty level. So you might be asked to simplify algebraic expressions with quadratics. Now, to be able to do this, you need to be able to factorize quadratic equations. And I'm just going to factorize this quadratic equation. So what we need to be able to do is to add 2 numbers to get 5 and multiply the same 2 numbers to get 6. So add 2 numbers to get 5, multiply the same 2 numbers to get 6. Now, I'm not going to spend too much time on factorizing quadratics. I've done other lessons on this, so you can have a look at those. But this is going to be, well, what are the factors of 6? The factors of 6 are 1 and 6, but 1 and 6 won't make 5. 2 and 3, well, 2 and 3, if we add them together, will make 5. So 2 and 5 will satisfy both conditions. So the way we would factorize this is we can write x plus 2 multiplied by x plus 5 in brackets. And if we were to expand this, we would end up with this quadratic expression here. So this is how we would factorize a quadratic. Figure out the 2 numbers that you're looking for, and then it will simply be x plus 2 and then x plus 5 in brackets. And if I just clear that up and carry on. So on the top, we have 5x squared plus 15x. We need to factorize this. So we'll have 5x on the outside. We will have x plus 3 on the inside. 5x times x is 5x squared. 5x times 3 is 15x. Now we need to see what will cancel out. And I've made a huge mistake here. I've written 2 and 5. That should be 2 and 3. So I do apologize for that. And this is why it's not adding up. So if you spotted it and you were shouting at the screen, well done to you. So that's going to be 2 and 3. That makes 5. So in here, we're going to have 2 and 3. So x plus 2 and x plus 3. So I do apologize for earlier. I did write the wrong number up here and as a result in here. So now we can simplify. So we have x plus 3 over x plus 3. These will cancel out. So what we'll have is 5x over x plus 2. And again, be wary, this x and this x are not going to cancel out because we're adding x to 2, whereas here we're multiplying 5 by x. These two will therefore not cancel out. So our final answer is simply going to be 5x over x plus 2. Let's do one more example. And if I just clear all the drawings, we have x squared plus 5x over x squared plus 7x plus 10. Again, we need to factorize this, so you can pause the video and have a go. But to factorize this, I need to have 2 numbers that add to give me 7, the same 2 numbers that multiply to give me 10. So add to give me 7, same 2 numbers that multiply to give me 10. So the factors of 10 are 1 and 10, but 1 and 10 won't work over here. 2 and 5, well, 2 plus 5 will give me 7, so 2 and 5 will work. So how I'm going to write this is x squared plus 5x is the same as, so this will become x plus 2, x plus 5. So the factorized expression becomes this. So I will write this as x squared plus 5x over x plus 2 and x plus 5 in the brackets. I can't factorize this anymore, but I can factorize the numerator. So inside the bracket, or outside the bracket, I should say, we'll have x plus 5. X times x is x squared. X times 5 is 5x. So x plus 5 and x plus 5 will cancel out. So what we'll have is x over x plus 2. And again, these x's will not cancel out because we're adding x to 2. X is not a factor of 2. We're not multiplying 2 by x. So be aware of that. Your final answer is going to be x over x plus 2. Right, boys and girls, I hope you found this useful and have a very good day. Bye.